Hello, I'm Bo from Sweden. Welcome to my channel about the WICS Project. Today we're looking into MP3 soundboards. We won't waste any time, so let's start. We have made 3 MP3 PCB with the same functionality and the same Xiaomi ESP32S3 microcontroller. First we have the small 3-watt MP3 PCB. Then we have the medium 5-watt MP3 PCB and the 10-20-watt PCB. To all the PCB, you have an option to connect the speaker switch and an option to add the RX480E 4-button remote control. nowRail have support for the 5 and 10-20-watt PCB, but for the 3-watt, you need to add the WICS add-on software. nowRail also have support for controlling speaker switch since it's using the 74HI595N shift register. As an option, the speaker switch PCB can be used to connect many speakers to one MP3 module. Through the control cable from the MP3 PCB and the speaker out cable from the MP3 module, up to 8 speakers can be connected. From the WICS configuration file, you can assign which speaker that should be used when a certain track is played.
For the 3-watt PCB Max 98357A, module is plugged in using the ESP32 flash memory fs to store the PM3 files. The 5-watt PCB is connecting either the DY-SV8F that have 8 megabytes flash memory or the DY-SV5-watt where you use 32 gigabytes micro SD card to store the MP3 files. The 10-20-watt PCB is connecting the DY-HV8F that also have 8 megabyte flash memory or the DY-DV20T that use 32 gigabytes micro CD card to store the MP3 files. From this MP3 modules, you have 10 watt with 4 ohm and 20 watt with 8 ohm speakers. Speakers need to be installed on the layout. We want them to be as small as possible, but at the same time deliver good sound quality. It's a tricky combination. The 3-watt 4 ohm is a small speaker that could be used for announcement on a train station and non-bass background sounds like railway crossing. Stone 5-watt 8 ohm speaker gives you the sound quality of a tablet. Ashta 10-watt 8 ohm is a speaker that gives you the sound quality of a TV. For bass demanding sounds, the Stone 48, 98, 20 watt 4 ohm speakers could be used, but it will need an enclosure.
To get any sound out of the speakers, we need MP3 files. You can download ready-made files from several locations. Here are 3 examples: BBC Sound Effects, pixabay.com and freesound.org. You can also have AI to make sound. 11labs.io, Stable Audio and AudioCraft is example of powerful AI sound engines. Of course you can record and modify your own sound. The Audacity software is free to download and use, and there are YouTube videos describing how to use the software and how to make sound effects, especially for model railroads. The MP3 files is saved in the number format. No names, just the number. This is the track number that you assign to a DCC address. Then the files need to be uploaded to the module. For the DY modules, you either use the micro USB cable for uploading to the flash memory, or you save the files to a micro SD card. For the MAX 98357A module, you use the little FS file system on the ESP32. Either use a USB-C cable and ESP connect, or use WICS Wi-Fi to upload the MP3 files to little FS. To control the MP3 boards, a configuration text file is used. The setting for the A to D buttons, scheduled DCC commands, and Wi-Fi settings is almost the same as for the gateway board. There is two types of settings for the MP3. The first, MP3 module, is used to assign which MP3 module that is used and if a speaker switch is used. The second, MP3 track, is handling the DCC address for a certain MP3 track. The logic for a start and end track if multiple tracks should be played, if the track should be repeated, and if it should be played in a sequence or in random order. Finally, the volume and what speaker that should be used.
Thank you for watching this video. Hope you enjoyed it. We look forward to sharing our next video with you. Until next time, take care and happy railroading.